Hey, g'day, it's Prezzo here, back in the shop, and this is part 3 of the sexy Lixie Art Deco inspired digital clock. And what you've been watching up until this point has been me preparing this material to make the clock case. This video is all about woodworking, and what you would have seen me do here is to lay out all of the pieces, make sure I had my face and edge marks on all of the frame pieces. I've numbered all of the joints because each joint is different. And they're all left and right handed, and as you can see it's thicker at this edge or this end than it is at this end, so none of the parts are interchangeable. And the other thing I did was I made extensive use of gauge pieces to get the sizes for the tenons and the offsets for the tenons from the inside face side of the frame, and I've used my table saw just to create these sockets and tenons. Now, the question is, why did I use MDF? Well, I realised that if I made this out of solid wood, I would have to cut out this large rectangular pocket on the inside here, which was going to be problematic. If I used individual pieces like I have here, I'm always going to get some end grain showing somewhere on the frame, which I didn't want. I also just couldn't find the type of wood that I wanted. So what I've decided to do instead is to veneer this whole contraption when I finished it, and I've got some beautiful Queensland walnut veneer, which is almost impossible to get now as solid wood, but you can get it as veneer, and I've been able to source just enough to make 2 clocks. Now, I said earlier on in the first episode of this that I was making one for myself, one for my son. The design of this thing is such that I have to be able to fit the Lixie modules inside this cavity, and I sized this so that it would just fit. There's not a lot of room to play with there, and the height is going to be dictated by the total height of the Lixie units, and the circuit boards and the wiring and everything for this is going to have to fit inside a large pocket in this piece here. So in fact that piece is separate. If I pull this apart, come on, there it is. If I pull this apart, you can see that I'm going to have to cut out this whole section, this complete part, to make room for the wiring and the circuit boards and the microcontroller. And when I do that, it's going to be left with just this section which carries the mortise, this very thin strip in the front, and the same on the other end. So it's going to lose nearly all of its strength when I do that. So as soon as that process is done, I'm going to glue it and laminate it back onto this base piece, which will make up the correct height that I want. So I'm about to do that now. I'm going to start by roughing it out in the bandsaw. I'm going to finish it on the table saw, and then straight away I'll get this laminated together so it retains its strength. So that's where we're going with it. Let's have some fun. Anyway. I just can't get at this corner here because of the depth of throat on my bandsaw, so I'm going to use the table saw to trim up these 2 edges, this one and this one, and I'm going to try and use the saw to trim along this edge here and just get that accurate. It doesn't need to be accurate all the way through, it's just where the Lixie modules fit down, probably only 6mm from this edge, but I'll try and clean the whole lot up. Okay, this is my plan to be able to cut these edges. I've got my saw blade set to the correct height to match up with the, you can see it better on this edge. This is the scribe line that I put along this edge, 10mm inside the face edge, and I've run the bandsaw as close as I can to that, but it's not perfectly straight. And I was going to run the blade against the end squared line at both ends, and I was then going to run this stock across the top of the blade to be able to depth that to the correct dimension. The only problem with this is that this piece is now quite flexible, so there's a fair chance it's going to buck and whip and carry on while I do that, but I'll just work it slowly backwards and forwards and we'll see how we get on. So I've already done Have I done that? Yeah, I've already done this end. So let's just turn this around and do this one. It's a little bit precarious. That worked alright. It sort of didn't quite get all the way through the back there. I'm just a bit worried about cutting the back of my sled too deep. I can trim that up with a chisel when I'm done. Well, that was exciting. I forgot that piece had been cut right through to the corner there. Anyway, it's gone now. Well, I completely abandoned that last setup. It was just way too scary for me. The chances of this machining accurately were just about nil, and I had a lot of stick out on the blade, so I just decided to do this with a spoke shape. So I can work along there and just plane out the discrepancies. The only thing I need to be careful of is this end piece. If I hit that with the spoke shave, it's going to knock that right off. The thing about this medium density fibreboard is that it separates very easily along its laminations. And for the same reason, I reinforced this section of the wood here with super thin CA adhesive. Yesterday when I was trial fitting one of these joints here, I could see this was going to come loose and break off, so just putting that super thin CA in there, it sucks into the end grain or the fibres and it locks it in tight, so that should prevent that from breaking away. Incidentally, does anybody else remember an ad back in the 1980s by Edward Woodward? And he was promoting Craftwood, which was the brand name given to this product when it first got commercialised. And he made a bit of a pun about his name in the whole ad, and for some reason it just stuck with me. I've always remembered that ad. It was quite clever.
Would wood give you a knot-free board that can be machined as cleanly as this? Craftwood would. Would wood give you a finish this smooth without hours of sanding? Craftwood would. You see, Craftwood will where wood wouldn't. Oh, my name isn't Edward Woodward.
Yeah, funny. I pretty much got that back to the line in the centre there, but of course these internal corners are going to be the problem. I'm just going to try this little bullnose plane. It's got me a bit closer. That's pretty good. It's a little bit here at the end. Okay, I've just gone through and I've straightened that section there. I've checked it. I've sanded that smooth, and this section can now be glued down to this base piece. The bottom frame of the Lixie display unit will fit flush with the top edge or the top surface of the piece that I've just cut out, and the space underneath here is for all of the wiring and the connectors and so on. The microcontroller is going to fit somewhere in there as well, but I'll probably make a cutout for that to go in so I can get at it from the bottom of the clock. That'll just give me a little bit more room to attend to all the wiring for that as well. Now, before I can completely assemble this, these side risers here are going to be veneered. They're going to be visible from the front of the clock. If I just turn this around, we'll get the idea. So I'm going to be able to see through to this inside surface here. So it's going to be veneered, and then later on when we completely finish the clock, that will be finished as well. This top edge here is going to be covered by a brass bezel and a small, very thin section of timber, and I'll use solid timber for that, and that'll be then flush through to the interior of the clock. So let's get all of the gluing done for the base pieces, and then we'll have a look at the veneer work for that riser. Before I can go ahead and assemble this complete frame, what I need to do is to veneer these two inside faces on these styles or risers, whatever you like to call them. And the glue that I'm using is a tight bond product, specifically for veneer work, and I've used this before, and it grips quite well. It takes about an hour to set up in this sort of weather. Gives you plenty of setup time so you can get all your clamps on. These parts are not particularly difficult to do. I'm just going to put the glue on, put my veneer on. The veneer is cut so it's a little bit bigger than I need it. I'll trim that back after, and then I'll just invert those and put a couple of clamps on. This is the Queensland walnut veneer that I got for this job. It's surprisingly thick. It's about 0.68, 0.7, something like that thick. Which in some respects is a good thing. It means that I can get a decent radius on these edges. I don't want to have razor sharp edges on this clock, but it does mean also that when I want to wrap this around the curve at the end of the clock frame, it could be a little bit more difficult to get a good strong bond there. So I'm just going to go ahead and coat these with the glue, and we'll get these clamped up. I've got some parchment paper or baking paper on here and a couple of sheets of newspaper just to give me a fairly resilient face to clamp that against, just in case my surfaces aren't perfect. I'll just put a scrap block on top there, get some clamps on this. I'm doing these one at a time because this MDF sucks up the glue very quickly, and I want to get the clamps on while that glue film is still quite wet. Okay, that's one done. I'll get the other one done and we'll meet back later when it's all set. Okay, well, I've just done a trial fit. I've clamped this up dry, that is with no glue, and I've just tried to be very, very careful about getting these inside edges to close up really tight. I did have to adjust a couple of these tenons, cut them back a little bit to make sure that they weren't bottoming out and leaving a gap on the inside. I have sanded that veneer on the inside face there already. I've done that with 240 grit paper and got that nice and slick. I've trimmed all the edges to make sure that's sort of already tidied up. And underneath I've cut a pocket in the bottom of the case. And this is where the microcontroller is going to sit, and that will be later on covered up by a foot, and the foot will be screwed down with a couple of screws, and that means that I can get at the microcontroller to wire up the pins and swap it out if necessary, but it does give me that access without sort of having to fiddle around inside the clock. So that's going to happen later on. I'll put a little bezel on the back here to hide the back of the microcontroller, and it'll have a port for the power, the reset button, and the micro USB. So on the front of the clock there's going to be a brass bezel that's going to be fitted all the way around the opening, and that means that I don't have to worry too much about getting these edges really, really crisp and clean. It's all going to be covered up. But it does mean that I've got a very narrow strip. It'll be about 4 or 5 millimeters wide behind that brass, and I can either cover that with a very thin strip of veneer, or I can just stain that black so that it matches the black acrylic which is going to go behind that edge. So that's going to be a thing for the future. So I'm just going to use plain old PVA glue for gluing this. A couple of G clamps. It doesn't need to be really racked up tight. And I'll just need to be very careful. I've checked that for square on the inside of that rectangular opening. Okay, let's get it buttoned up. It's a technique that I learned a while ago for checking a frame for square. Basically what you want to have is the diagonals equal. So if you take two of these steel rules and just hold them together and extend them till they touch the inside diagonal corners and hold it, and then just check it the other way. And it should just slide in, and if you put the two rounded corners on the outside edge, it'll enter that corner and you can check it. And if there's any discrepancy, so if you have one diagonal longer than the other, you need to move the clamps toward the longer diagonal to compress it. So in this case I just got lucky and it was correct first time round. So I'm going to let that set now, and then we can start the process of getting all the shaping on the outside done, getting all this cleaned up. Looks a bit ugly at the moment, but it's trust me, it's going to look better than this. Okay, let's let it set. Oh, incidentally, these little silicone glue brushes are brilliant. This one's Rockler, and you can wash them out later, and because of silicone, the glue doesn't stick, and it sort of gives you just enough without it dripping off there, and it leaves that textured finish in the glue, which means that when you press the two surfaces together, it's got some air in there as well to allow the glue film to escape. So yeah, they're great. Well, there we go. There's 2 clock cases nearly finished. There's a little bit of work still to be done underneath here. There has to be 2 feet made just to finish off the form of the clock. And unfortunately, I do not have any of this Queensland walnut as solid wood. What I have got is some Malaysian teak, and I've got enough of this to make all the parts that I need. Now, Malaysian teak's not even the same species, not even the same textural colour, but I'm hoping that if you squint and use your imagination, it's going to look pretty close. So I'll do some work with stains in the finishing process to try and match it up as close as I can. But it has got a nice grain, so I think it's going to work. Now, the next step is going to be to veneer all of this MDF. And it's too big a job to do in this video, so I'm going to hold it over for the next one. So in that video we'll look at attaching all of the veneer on the outside of the clock. And you'd think that's pretty straightforward, just glue and clamp it down. But the difficulty is going to be on these curved surfaces. So the veneer is going to be bent around that form and held in place while the glue sets. Now, traditionally this would have been done with a hide glue, that is an animal-based glue, put on hot, and then the veneer would be rubbed down with a veneer hammer, which is just a brass-edged tool to wrap the veneer around as that hide glue cools down and sets. Now, I've never done it before. I understand the process, but look, it's a bit scary for me. I'm just going to use that tight bond glue, and I'll make a caul, that's C-A-U-L, a caul, out of polystyrene foam and a bending plywood, which is very flexible, and it'll wrap around that, and I'll use a strap clamp to hold it all in place, and I'm pretty sure that's going to work. So I'm starting to prep all my veneer now, getting that ready, and we'll look at that in the next video. The other thing we'll be doing next is to make the little brass bezel that goes around the opening. I've already got the brass angle for doing that. It needs a bit of machining to get it to the correct dimensions, and that will be silver soldered together as a single piece, and I'm going to try nickel plating it just to give it that nice retro appearance. So we'll look at that in the next one as well. So thanks for sticking with me on this. It's a lot of just doing stuff. I didn't explain too much about what I was doing here, but I think you get the drift. So catch up with me on the next one, and we're going to have some more fun. Okay, thanks for watching.